Introducing Hunger Games, The Ride.
Hello, Six Flags Amusement Park. My name is Hayden Garnick.
And my name is Dylan Winget.
Here at the start of our ride, we start at 1.2 meters high and take a devastating 0.9 meter drop to our first loop, and then a 0.6 meter slope to our second loop, and a 0.9 meter roll to the end of our ride.
The time of the ride is 4.2 seconds and the length is 4.22 meters. The mass of the marble is 0.64 kilograms.
The average speed of this ride I found was 1 meter per second. I got this by dividing the distance by time. The acceleration of the marble is 0.24 meters per second squared. I found this by dividing 1 by 4.22. The force of the marble at one point on the ride is 0.1536 newtons, because 0.64 times 0.24 equals 0.1536.
The potential energy is mass times height times gravity, and in this case equals to 7.52 joules.
The kinetic energy is 0.32 joules. I got that because multiplying 0.64 and 1 to the second power, and then dividing all of that by 2. And that equals 0.32 joules. Okay, so positive acceleration is going from being still or moving very slowly to going much faster. Like in this case, it went from still to going very fast. If you could even see the marble. Okay. And then negative acceleration is going from moving to a stop or going very slowly or slower. In this case, the friction is what's stopping it. This is also a form of Newton's first law. See? Which an object in motion will stay in motion unless acted upon by an outside force. The outside force was the friction in this case.
Newton's first law is represented in the ride by, at the end, when you roll it, it hits the end and is stopped by friction and by the cornucopia. But sometimes when it's held, it bounces off, which represents Newton's third law.
So the highest potential energy would be right here, and the lowest potential energy would be right here. Because as the potential energy goes away, the kinetic energy goes up. So right here would be the highest, the lowest part of the kinetic energy, and right here would be the highest part of the kinetic energy. Let me demonstrate with the loop. So the loop right here is the highest potential energy, and right here would be the lowest potential energy. So let's show. Marble. I'll show you with this one. Did you see how it slowed down right here? How when it got slower right here?
As the marble rolls down, when it goes up the loop, when it gets to about here, friction starts applying itself and it starts to slow down towards the top. But when it drops again, is where the kinetic energy pulls in and it makes it go. But at the end right here, it also has a lot of friction. If you were to just go like this, it stops.
Thank you, Six Flags Amusement Park, for listening. We hope you choose our idea for your next big roller coaster.